Hello guys, welcome to my channel. So today we are going to talk about Java 21 interview questions. So this is the most latest version of Java which a lot of Java developers are currently using. So this is going to be a hot topic in coming days. So you should be aware of the new features that were added in Java 21 and related interview questions. So in this video we are going to talk about every new feature that was added in Java 21 and the interview questions that can be asked to related to those features. So before we actually look into those questions, if you are new to my channel, if you haven't yet subscribed to my channel yet, guys, please do. It is very disheartening to see that a lot of people are watching my videos but not subscribing, so please do that. And now let's kickstart this video. So the very first question is, what are the new features introduced in Java 21? So talking about the first feature, it is record patterns. So records were actually introduced in Java 14 as a preview feature, and in Java 16 we officially got that feature. So records were a way to model immutable data in a concise and readable manner. Now this is not a new feature, but what we got in Java 21 was record patterns. So what is that? So this feature actually allows you to deconstruct records more easily and use patterns to match and extract data from record instances. So pattern matching allows you to match against record types and extract their components. This feature is integrated with switch statements and instance of checks, making it easier to work with complex data structures. So now what are we getting by using this record pattern matching? So we get conciseness, which actually reduces boilerplate code by eliminating the need for manual extraction of record components. We get readability, makes the intent of your code clear and easier to understand. We get safety because it provides a more type safe way to handle different kind of data structures. Now the second feature that we got was pattern matching for switch. So this is not a new feature. This feature we got as a preview in Java 12, and officially this feature was added in Java 17. Now there were few enhancements in Java 21. So in Java 21, pattern matching for switch has become more flexible and expressive. It includes improvements such as enhanced pattern matching, record patterns and null patterns. So now with record patterns you can match and deconstruct or destructure record types directly in the switch statement, which we have already talked about. We get null patterns. The case null pattern allows you to explicitly handle null values in switch expressions. We get pattern guards, and this pattern guards using when are still available to add additional conditions to cases, improving flexibility. We also get enhanced type patterns, which are there to support type patterns for matching types and extracting values in one step. Now the third feature is virtual threads. So virtual threads are a significant enhancement to Java concurrency model, which provides us a new way to handle high concurrency workloads more efficiently. Now what are they actually? So these are lightweight threads managed by JVM rather than by the OS. Unlike your traditional platform threads, virtual threads are designed to handle many more concurrent tasks efficiently. This is particularly useful for applications that require handling a large number of input-output bound operations that spend a lot of time waiting. Right. So the benefits that we are getting with virtual threads are lightweight, scalable concurrency, simplified programming model. Why it is simplified? Because it allows you to write code that looks and behaves like traditional thread-based code, but with much greater scalability. Also we get integration with existing APIs, so we can use executor service and completable feature, which were introduced in Java 8 to make it easier to adopt without major changes to existing code bases. Now we got string templates in Java 21. So this is a completely new feature, and this provides us a new way to work with strings that makes it easier to include expressions and variables within string literals. This is basically to simplify the construction of complex strings and improve readability. Now the key features that we are getting are your embedded expressions, improved readability, compile time safety, and flexibility. Now the next feature is your value types. This is actually a preview feature in Java 21, and this is to extend the existing capabilities of sealed classes to interfaces. So sealed interface provide a way to restrict which class or interface can implement a particular interface. This is going to improve the design of APIs and frameworks by offering more control over the type hierarchy and ensuring that a specific type of set of types are the only ones that can implement or extend the sealed interface. So the key features that we are getting is controlled extensibility, pattern matching, because we can use expressive switch statements. We get improved API design because you can design more predictable and controlled APIs. Now the last feature is your foreign memory and memory API. So basically this is a part of Project Panama, which continues to evolve even right now, offering a more robust and flexible way to interact with native code and manage native memory from Java. This actually provides you a safer and more efficient alternative to the traditional Java native interface, commonly known as JNI. This allows Java programs to interface with native libraries and manage off-heap memory with improved performance and safety. So the key features that we are getting is safe interfacing with native code. So this actually provides you an efficient way to call native functions and handle native memory when we compare it to JNI. Now we also get direct memory access, so it allows us to access and manipulate off-heap memory directly, which can be useful for performance critical applications. Also it provides us enhanced performance because rather than using, like, if previously we were using traditional JNI, so it provides more direct access to native resources, right, like we talked about, and this actually reduces the overhead associated with JNI calls. The last key feature we get is improved API design. So it offers some modern and developer friendly API compared to JNI, which kind of looks pretty old, and it actually makes it easier to use and less error prone. Now these were the new features introduced in Java 21. The next question is explain the enhancements to record class. So this we have talked about in brief, so we will going to take a look at code also, but theoretically we got two things: record patterns, we got enhanced equality and hash code methods. So with record patterns we can now use record patterns to destructure records directly within pattern matching constructs. This simplifies working with records and improve code readability. With enhanced equality and hash code methods, we get improvement to ensure that we have better consistency and efficiency in methods like equals and hash code. Now let's take a look at the record class. Alright, so first let's take a look at a record. So how do we create it? So it's simply going to be like this, and let's say person. Alright, so a record will have a keyword record. So I'm going to have string name and int age. So here in this example, person is a record with two fields, name and age. In this case, Java compiler automatically provides implementation for toString, equals and hash code, and a constructor that takes the name and age as parameters. So let's say if I have to use it, so let's use this main class here. So here what I will do is let's do south. So I need a person object first. So person equals to new person, and here let's say Shriram. Let's do John Doe, and age as let's say 21. Alright, now I want to print the name and age, so person dot name. So here if you see, we got the method and then person dot age. Alright, now let's say if I want to use the toString method, so for that I can directly use person object, so it will print me both the name and age. Now let's say if I have to use equals and hash code, so for that I need another person, so person let's say second person equals to new person, and here I'll say Jane Doe and age let's say 22. Alright, so here I'll use South again, and here what I will do is I will use equals, so person dot equals, and here I will say second person, and then let's do person dot hash code. Alright, now I'll take another example, and here what I will do, so here I will keep age as same and name also as same, right? So let's see what the output will be. Now let's run this. So here what do we have? We got the first name and then age, two things. Then we have this toString, so here we got both name and age. Then we compared with equals and we got false because we are comparing Jane Doe with John Doe, and that's okay. We got the hash code. In the second case we got true and we got the same hash code, right? So whatever we were getting with records, we have seen it, and because we don't actually provide any method, it comes by default to us. So that's how you can create a record in Java. Now talking about what did we got new, so we got pattern matching with records, right? So to take an example, let me remove everything from here. I'll keep this person object, and here what I will do is I will use a switch statement, so string description equals to switch, and here I will provide the object which is your person. And then what I will do is I will have a case, so this case is going to be of type person. Here I will provide what do I want to get. Here I want to provide the arguments, so string first argument is your name, and then you have int age, right? Then using lambda expressions I will use name plus is, then plus, then age, and then years old, right? So here I created an statement. Now the default case that we need obviously is going to be unknown person. Or you can do NA also, right? Now use system.out.println and print description. So here what we are saying is, in the switch statement, person is a pattern that matches instance of person. In that case, deconstruct the person into two components, name and age, and then whatever I would like to do with the name and age I can do, right? So this is one of the way to deconstruct. So first let's see this one. So this is the first way. Now second is your instance of. So here what I will do is I will go with the same logic, but here I'll use an object because I want to do instance of, and you know that object class is actually a parent of every class. So here I will say Jane Doe. Somehow the shift is not working for me in the keyboard. Okay, now what I will do is I will use if condition, if obj instance of person, right? Then deconstruct it into two arguments, name and age, and then in that case I can do whatever I want. So I want this to be printed. So this one is more efficient approach, but if you like switch, then you can use switch. Alright, so now let's run this. Let's see what we are getting. Okay, so we got something like this. So here I added this space, and let's run it again. So John Doe is 21 years old, Jane Doe is 21 years old, right? So this is what we got in Java 21. So the benefit that here we are getting is conciseness, because if you can see, it reduces boilerplate code by eliminating the need for manual extraction. It is more readable, as you can see. It makes your code clean and easier to understand. Also, it provides you type safety. Moving on, how has pattern matching been improved in Java 21? So in Java 21, we get pattern matching for switch, which allows for more expressive and flexible switch expressions and statements. It simplifies complex switch statements by allowing patterns to be used in case labels, enabling a more concise and readable way to handle different types of input. So let's take a look at the example. Alright, so we have already seen pattern matching in records. Now let's see more example to pattern matching. So again, we have to use switch statement here. So I'll remove what we have used with record here. So let's do everything clean. So I'll create an object with hello Java. Okay, so traditional switch statements, let's take a look at it first. So string result equals to switch, and here I will provide the object on which I want to operate. So string obj, and then I will have cases. So case string. So if it is a string type, in that case I will do something like this. So I will say it is a string with value, and here I will say plus s. Similarly, I will have other types also. So string is done, then we will say integer, and let's do double also. So it's an integer, it's a double. Alright, and last is going to be our default. So I'll just say unknown type, something that we don't know. In that case, I will just print the result. So result. So this is your traditional way. So if I run this is going to work just fine. So here, if you see, it's a string with value hello Java. So it's working. Now we got enhanced patterns in Java 21. So what is there? So let me change the example a bit. So let's do 1 2 3. Now what additionally I can do is, let's resume. Okay, let's remove this one first because it's an integer now. So I want integer to be here first. So if it is an integer, in that case what I will do, I can use when condition, and I can say when I greater than 10. In that case, say that it is greater than 10. So here I will say number is greater than 10, or something like this. If I have I greater than 0, then I can say positive integer, and here I can print I, right? So the second condition could be something like this. So this is going to be your else condition. If it doesn't comes under this, in that case it is a negative number, right? So here I don't need a when condition. Here I can simply say negative integer, right? Now if it is a string, in that case I can print the length, maybe something like this. and here I can say string length. Alright, so default is going to be there, and I can run this. So here it says positive integer. If I do -123, in that case it will print negative integer. Alright, so this is what you got. Now key notes that you have to keep in mind. So here you can use type patterns to match and extract value in one step. Here what we are doing is we are doing something like this. So here it matches an integer and then assigning the value, the object value in I. Now guard clauses. So this is what we are talking about here. So when keyword allows you to add additional conditions which are guards to the cases, enhancing the flexibility of pattern matching. Now combining patterns. So we can also combine patterns and guards to handle more complex scenarios. So this default is pretty much standard, so we already know about it. Now let's take an example of person record also in this scenario. So what we can do is we can basically create a case. So case person, and here you know that we have already used, we want to reconstruct, right? So something like this we can also do, and here I can print whatever I want. So like person name, and then the name, and then aged, and then age, something like this. Alright, so there could be another scenario that you can also check for null. So if your object is null, then you can say it is null. Sounds good? So this will also work because we have already created person. So let's run this. So here we have to change this. So let's say new person, and here I will say Sam, and then age as 32. So in this case, if I run this now, I got person named Sam, aged 32. Now I can also do object as null. So let me remove this. Now let's run this, and it's null. Alright, so this is it. Now let's move on. Moving on, what are the new capabilities of virtual threads in Java 21? So we talked about it in brief. So virtual threads are lightweight threads that aim to simplify concurrency by allowing you to create and manage thousands of concurrent tasks with minimal overhead. They use a virtualized stack and are managed by Java runtime, making them more efficient compared to traditional platform threads. Virtual threads improve scalability and reduce the complexity associated with traditional thread management. Now let's take a look at the example. So now in this example we are going to use executor service. So for that I first need to have an object of type executor service, and here I'm going to use executors, and then the method. Alright, something like this. Now what do we need? We have a service with us. Now we want to submit few tasks. So how do we do that? We use again executor service dot submit, and here what we will do is we will have something like this. Now inside here we will provide the logic. So I can use system.out.println to say that this is a virtual thread, and then I can use thread.sleep to sleep for 1 second. So this is an example for a blocking call. Then again I'll use system.out.println, and here I'll say virtual thread work completed. Now I need to handle try catch here, so I'll just surround it, something like this. Now if I run this, So you see that this is a virtual thread, then there was a delay for 1 second, and then virtual thread work completed. Alright, so this is your virtual thread. Now the benefits that here we are getting is your improved scalability, because virtual threads can handle a much larger number of concurrent tasks than your traditional threads. It reduced your resource consumption because it used fewer system resources, allowing your application to scale better. Now it also has simplified concurrency, and it is making things easier to write and manage concurrent code. And then it actually enhanced your performance by reducing the overhead associated with managing a large number of threads. Alright, moving on, discuss the updates to sealed classes in Java 21. So Java 21 extends sealed classes to interfaces, allowing you to control which classes or interface can implement or extend a sealed interface. This improves the safety and maintainability of type hierarchies by restricting subclassing and ensuring that all possible subclasses are known and accountable for. Now let's take a look at the example. Now let's talk about sealed interfaces. So for this I need to create an interface. So interface, and here let's say I'm going to work on animal. Alright, so I like animals. That's why animal. So public sealed. Now we have a keyword sealed here. Now what I want to do is I want to permit, as in I want only 2 classes to extend this interface. So I'll say dog and cat. Now these are not yet created, so that's why you're getting this error, but that's okay. Now I want to have a method which is void make sound. Alrighty, now let's create those classes. So first is going to be your dog. Now I want this to be implementing animal. Alright, now I have to override. So here what I will do is I'll simply print woof. Now here if you see that modifier sealed, non-sealed or final expected. So in this case I have to make this final and this will work. Similarly I have to create another class cat, and again I want to implement animal, make this class final, and then override the method, and here I'll just say meow. Alright, now let's use these in our main. So here I'll just say animal 1 equals to new, and first let's do dog, and then animal 2 new cat. Alright, then I can simply do shout, and here I'll just say animal 1 dot make sound, and similarly animal 2 dot make sound. Alright, so this is what you're getting if you run this. Alright, so my bad, we don't need to print anything, they will print by themselves. Now let's run this, and we got woof and meow. So this is how you can use sealed interfaces, and along with you can also use sealed classes. So what are you getting? You are getting more type safety, because by specifying which classes or interface you are permitting, you prevent unauthorized types from implementing your interface. You have predictable type hierarchies because it ensures that the type hierarchy is closed and predictable. You get more improved design because you making your interfaces more maintainable and robust by controlling the extensibility of types and ensuring that all possible implementations are known, right? You get better integration with pattern matching. So I haven't shown this example yet, so let me change this a bit. Let's create another one. So Java interface, and let's create shape. Alrighty, so this is going to be your seed interface, and here I want to permit circle and rectangle. So this example is specifically for pattern matching along with your sealed interfaces. So here I will have a method area which will return a double type. Right, now let's create circle and rectangle. So Java class first is your circle, and this is going to be your final class as we know, and this is going to implement shape. Then we need to override. So override. Now here what do I want to do? Here I want to do, let's say, return math dot pi, and then I need radius and then radius. So I don't have radius for now, so how do I get it? I will get it using a variable private final double radius, and then I will have a constructor public circle, and inside this I will get the radius, and then I'll just do this dot radius equals to radius, and here I'll just do radius and then radius. So everyone knows about the formula of an area of a circle, so this is the formula. Now let's do similar steps for rectangle. So I'm getting an error here. What is the error? Okay, this is the related error. Okay, that's okay. So final implements shape, and let's override. So here we don't get a radius, we get private final double width, and then we get height. Alright, now we want a constructor. So public rectangle, here double width, double height, then this dot width equals to width, this dot height equals to height. Alright, now talking about area. So area is pretty much simple, width into height. Alright, why are we having error here? It seems it's alright, but still we are getting error. Okay, no problem. Now coming back to main.java. So here let me remove this. So here shape1 equals to new circle, and here I'll say 5, and then shape2 equals to new rectangle, and here I'll just say 2, 3. Now I want to print the area, so shape1 dot area, and similarly shape2 dot area. Now talking about pattern matching. So what we can do is we can have a switch statement here of your shape1 object, right? So shape1 is circle, so we can have two cases here. One is your type circle and another case is going to be your rectangle. So here what I want to do is I want to use system.out.println, and here I'll just say it's a circle with area and then c dot area. Similarly, if it is a rectangle, then in that case rectangle and r rectangle. So right now let's run this. So currently as you can see, we got this area of circle, we got area of rectangle, then we got it's a circle with area. Now here if I do shape2, then it should be it's a rectangle. Alright, so it is working fine. So this is how you can use your sealed interfaces with pattern matching. Now let's move on to another one. Next question, how does Project Loom impact concurrency in Java 21? So Project Loom, as we know, introduced virtual threads, and virtual threads significantly impact concurrency by making it easier to write and manage concurrent code. Virtual threads enable high throughput applications with simpler and more manageable concurrency models, reducing the overhead and complexity of traditional thread-based concurrency. We have already talked about this, so we don't need to take a look at the example on this one. Moving on to the next question, what improvements have been made to the foreign function and memory API? So with improved APIs for interacting with native code, we got new methods and features, making it easier to allocate and manage native memory, interact with native libraries, and handle native data structures. And this again makes it easier to move from JNI to foreign function and memory API. Also, we got better support for performance and safety. So there have been a lot of enhancements which were specifically made to improve performance and safety when dealing with foreign functions and memory API. Moving on to the next question, explain the new string templates feature in Java 21. String templates provide a new way to create and manage strings with embedded expressions. Instead of using traditional string concatenation or formatting, you can use a template syntax to embed variables and expressions directly within the string, making code more readable and reducing the risk of errors. Now let's take a look at the example. Now for string template, I'll use my main class again and I'll remove everything from here. So let's take an example like string name equals to John and then age as 20. Now I want to print a message. So the traditional way is something like this. I will say person named, and then I'll just do name and then space is and then age years old. So this is our traditional way, right? Now what I can do more on this is so I'll use str dot and then here I'll just say same thing, person named and then your variable name is again your variable name years old. Now here let's import this str, and we are getting an error, is a preview API and may be removed in future release. So now I'll set to 21 for this. Now it worked, so I'm able to import. Alright, so my mistake, we had to use curly brackets here and I used something else. Now let's print these. Let's see. So we got person named John is 20 years old, and again same thing. So this was a traditional way. Now we can use something like this. So this is a preview feature in Java 21, and in the next release this is going to be your permanent feature. So here what are we getting? We are getting a str template processor. So this performs string interpolation by iteratively replacing each embedded expression of the provided template with the string field value of that expression. So this is your embedded expression and it will be replaced by the value of this variable name, right? So str here is a public static final field and is automatically imported into every Java compilation unit. Now let's take another example to have more functionality. So let's say that you have again a message and let's create a variable boolean here because I want to use a condition. So let's say is adult and here age greater than equals to 18, and here you know that the age is 20, so in that case this should be true. Now message 3, what do I want to do? I want to use str dot and then I'll say is adult. Now I want to print either true or false, so again I'll use curly brackets here and I'll say is adult, and here I want to use a conditional expression. So for this I can use something like this. In that case I'll do yes, if not then okay, this will not work, so something like this. Alright, so if it is an adult, as in if it is true, then in that case it will print yes, otherwise no, right? So this is another example of how you can use str as in string template. So message 3, now let's run this. Okay, so I got true, yes, no, so this actually didn't work. Did I miss something? Oh yes, I missed this. And now I have to use double quotes. Alright, so let's run it now. So is adult? Yes. So this is how you can use an entire conditional expression inside embedded expression. Alright, now let's move on to next one. Now next question, how does value type in Java 21 enhance performance? So value types are a new feature specifically aimed at improving performance and memory efficiency by providing a way to define immutable types that can be optimized by the JVM. Unlike traditional reference types, value types can be stored directly in arrays and objects, reducing the overhead of object allocation and improving cache locality. Okay, now let's talk about preview types. So let me clean everything from here. So we already created a record person previously, this one. So I'm going to use the same again because this is an immutable object and I can use value type on this. So what I will do is basically I will create two person object to compare. So person p1 goes to new person and here let's say the first thing is name, so John, and then age 21. Similarly, I will have same things like this, and let's create another object, and let's do Jane here and p3. So what value type actually does, so it's a type and you can use it to compare data, and it doesn't have any identity, so it's lightweight. Now what I want to do here is I want to use equality using equals and double equals. So first thing first, I'm going to use p1 dot equals p2. Remember here we have two values here, John and name and age. Similarly, I'll use for p3, and then I'll use p1 equals p2, and they both are equal, right? Now let's run this. So in the first one we got true because they both are same object, and two value types with the same data are considered equal. So these value types are actually having same data, so they both are equal. For the second case we got false because it's not equal. Now talking about third one, double equals operator, as we know, it checks if p1 and p2 refer to the same object in memory, which is false because they are different objects altogether. So that is why we got false in this case. Alright, now you can use value types in collection as well. So you can have list of person list, and new array list, something like this. Alright, so this is one more way that you can do. What else? You can use pattern matching with value types. So let's say if I want to do if let me scroll down a bit. Let's say if you want to do if p1 instance of, and then I'm doing point, and then I'm doing person, and inside here I will have string name int age, something like this. If it is an instance of person, in that case I want to do person named, and here I can use a string template, so that is additional one thing. So let's do that. So named, and then name is age years old. Alright, so here you got one more functionality with value type. Here we are using pattern matching. So let's run this. So you got this. Alrighty, now let's move on to next one. Moving on, what are the benefits of patterns matching for switch introduced in Java 21? So we already talked about this. So pattern matching allows for more expressive and concise switch statements by enabling patterns to be used in case labels. This feature simplifies complex switch logic, improves code readability, and reduces the need for nested switch or if-else statements. So we have already taken a lot of examples to discuss the new features, but again let's take a look. So how does the record class in Java 21 differ from earlier versions? So as you know, record class was already there before Java 21. So what is different? So records in Java 21 now support record patterns, allowing them to be used in pattern matching expressions. This enhancement simplifies the process of destructuring records, making it easier to access and manipulate individual components. Now describe the new syntax and capabilities introduced in pattern matching for instance of in Java 21. So pattern matching for instance of introduced a new syntax that allows you to test and cast objects in a single operation. So here if you see, the first example says if object instance of string, in that case I'm using a new variable string s, converting it from object to string. But now what you can do is you can use object instance of and then string s. So here you are defining it in a single operation, so it is actually reducing line of code for you, and it simplifies and it's look more readable. So this feature simplifies type checks and cast, reducing boilerplate code and improving readability. Now what are virtual threads? How do they improve scalability in Java 21? So talking about scalability, so because these are lightweight threads, so it reduces overhead, first thing, right? So it is more light than your traditional threads. Now they are managed by JVM rather than OS, so it allows you to create more number of concurrent tasks with minimal resource consumption, because there is no overhead, there is minimal overhead. So what does it provide you? It provides you more scalability by making it easier to handle high level of concurrency without significant performance degradation. So that is how you get more scalability with virtual threads. How does Java 21 improve the usability of sealed interfaces and sealed classes? So as you know, sealed classes were already there, but sealed interfaces was introduced as a preview feature in Java 21. So what do we get is in sealed interfaces we extend the concept of sealed classes, right? Now this allows you to restrict which class or interface can implement or extend a sealed interface. So here you can have more restriction, or you have more control over what you want to use. So this actually provides you a greater control over type hierarchies, and this improves safety because you get more control. So this ensures that all possible subclasses are known, making code more maintainable and easier to reason about. How does string templates simplify string handling and formatting in Java 21? So string templates allows you to embed expressions directly within string literals using a new template syntax. This feature simplifies string formatting and reduces the need of concatenation or complex formatting methods. So in this example you can see in the first one we have string name equals to word, but in the second one what we are doing is we are concatenating the variable name with hello, right? Here you are actually simplifying what you want to do using your string templates. So this makes it easier to create and manage strings with embedded variables and expression. And if you have used maybe Angular or maybe TypeScript, you know, like this is a new way of writing more readable or more creative code. So yeah, new way to write strings. Explain how value types can be used to optimize performance and memory uses in Java 21. So specifically talking about performance and memory usage, value types are designed to be immutable. So when we talk about immutability, we get memory performance by default, right? And it can be stored directly in memory rather than as objects. So it again provides you more performance because you don't have to bother about where to store it in memory. This reduces the overhead of object allocation, improves cache locality. Value types are especially useful for representing simple immutable data structures that do not require object identity. Alright, so that's how you get more performance and memory optimization. What is the significance of pattern matching for switch in Java 21 and how does it affect code readability and maintainability? So specifically this question is for code readability and maintenance. So in this pattern matching logic we get more easier way to handle complex conditional logic. So because of which we get more code readability and it reduces your boilerplate code, which eliminates the need of nested switch or if-else statement. So that is how you get code readability and maintenance. Now advanced Java 21 concepts. How can you leverage virtual threads to improve the performance of input-output bound applications in Java 21? So virtual threads are particularly useful for input-output bound applications, which we have already talked about, because they allow you to handle many concurrent I/O operations with minimal overhead. Since virtual threads are lightweight, you can create thousands of them to handle concurrent I/O operations efficiently. This reduces the need for complex thread management and improves overall performance. Now, last question, what are the potential use cases and benefits of value types in modern Java applications? So first thing is, it represents immutable data structure. So string was already immutable, so you know about it, what immutable provides you. So value types are ideal for representing simple immutable data that does not require identity. You get performance because value types can reduce the overhead of object allocation and improve cache efficiency. We get optimized memory usage because there is no overhead of reference types, and value types can help reduce memory consumption, which we have already talked about multiple times. So these were the questions that I wanted to talk about in this video. So if you have any questions, do let me know on the comment section of this video. If you have any suggestion, also let me know. And this is it for this video. I really hope that we will meet in some another video. Till then, stay happy, keep learning, and bye bye.